Welcome back to Maths with Mrs. J. In our previous video, we talked about the discriminant. That's the part under the square root sign in your quadratic formula. And we talked about how important it was in telling us information about what sort of solutions we're going to get, if any, to a quadratic equation. And also it tells us information about the quadratic expression itself as to whether it is able to be factorised with rational numbers, whether it's perhaps a perfect square, or perhaps maybe it can't even be factorised at all in the real number system. Now, by the time you get up to this stage, I would think that you would look at this first example and automatically be able to factorise that. However, just to prove that the discriminant can come in handy, let's say we weren't sure if that could be factorised or not. Let's work out the discriminant. It's b squared minus 4ac. So it's our negative 3 squared minus 4 times 1 times 2. So it's 9 minus 8, so it's 1. So your discriminant is a perfect square. That's proof that this can in fact be factorised. So let's do that factorisation now. This is an easy one to factorise because there's just really a 1 in front of our x squared. So we're looking to make our two brackets with an x at the start of each one. And we're looking for two numbers that multiply to give positive 2 and add to give negative 3. So negative 1 and negative 2 will fit the bill there. So x is 1 or 2. Would it be wrong if you used the quadratic formula to solve that? Well, not really, but it's not really the most appropriate method. You're taking a lot longer to do something that really should just be a two-step situation. Normally, I wouldn't even bother working out the discriminant for something that's very obviously able to be factorised. All right, we just did that for an exercise here just to prove that it can be. Let's have a look at this next one. So let's work out the discriminant. So b squared minus 4ac. So it's 3 squared minus 4 times 1 times 9, which is 9 minus 36, which is negative 27. Okay. Alrighty, in this case, our discriminant is negative. So even if we tried to use our quadratic formula, we would get to a point where we're not able to continue and get any real solutions. It's okay to, just at this stage, say, therefore, no real solutions. There's no need to go all the way through your quadratic formula to prove that there are no real solutions. If you can just state that the discriminant is negative and give some working to show that, that's perfectly adequate. All right, let's go on and do one more lot of examples. Okay, now again, I would expect that by this stage, hopefully, you are fairly well acquainted with recognising what this is. Hopefully, you will recognise that this is a perfect square. So hopefully, you would be able to go straight to x minus 3 squared is 0. So x is 3. We can call that sometimes people would call that a repeated solution because it's like x is 3 or x is 3. Okay, so there's really only one solution there. If you weren't sure that that was a perfect square, what you could do is you could work out the discriminant, which is negative 6 squared minus 4 by 1 by 9, which is 36 minus 36, which is 0. If your discriminant comes out to 0, we know that we're dealing with a perfect square. Okay, that the quadratic expression is a perfect square, and therefore using that method to solve would be the quickest and easiest way to do it. All right, last one for this video. So we're going to have a look at our b squared minus 4ac. It's pretty obvious by looking at this. Factors of negative 7, we can have negative 7 and 1 or 7 and negative 1. We're not going to be able to get that plus 4, are we? So it's pretty obvious that we're going to have to use a quadratic formula here anyway. So 4 squared minus 4 times 1 times negative 7. So that's 16 plus 28, which is what, 44. Okie dokie. We've already worked out the bit under the square root sign. So when we use our quadratic formula, our b squared minus 4ac, we've already done that calculation, which is kind of handy. So let's do this here. So plus or minus, what am I doing? B was 4. Let me just get rid of that. Helps if you substitute, doesn't it? So negative 4 plus or minus square root 44 all over 2. Now square root 44, I have done a series on surds, but just in case you're not sure how to simplify that, that's 4 by 11. So it's root 4 by root 11, which is 2 root 11. So we get negative 4 plus or minus 2 root 11 divided by 2. You can divide the 2 into each of those terms and you get negative 2 plus or minus square root 11. And as expected, the discriminant was positive, so yes, there are 2 solutions, but it's not a perfect square. The discriminant is not a perfect square, so our solutions that we get are going to be irrational.